Good morning, everyone.
Good morning, ma'am.
Among the 5 case studies, we have seen the first case study and the last case study, and today we'll be looking into the third case study. So this is case study on modules. Let us look into what exactly is the problem statement. The problem statement is that this is working on modules. So you just need to create a module, and the name of the module need to be prime. Okay, and so inside this module, like you need to create methods, okay, functions. The first function will be to check is prime or not. Okay, so the this function will check whether a given number is prime or not. That's it. Okay, and here it is specifically mentioned in the case study that it should written boolean whether the given number is prime or not. Okay, so do follow the case study accordingly. It is very important that your observation is good over here. Okay, so I'll just have a function which will be taking a number as an argument, and it will check whether the given number is prime or not, and it will return true or false. Okay, so that is what it will be, this function. And the next function that you will write in the same module, which is prime, is like is palindrome prime or not. So palindrome primes are the prime numbers. Palindrome is the number which is read the same way in the forward and the backward direction. So for example, 131 is a palindrome number, because when I read it in the forward direction, it will be 131. When I read it in the reverse also, it will be 131. So such kind of numbers are called as palindrome numbers. For example, for the words, like you can see, like liril is prime number, LIRIL, which is a palindrome number, and then Malayalam is a palindrome word. Okay, so liril is a palindrome word, and Malayalam is a palindrome word, and madam is a palindrome word. Okay, so all these are like which can be read from the forward and the backward direction without any difference. Okay, so that is called as a palindrome concept. But here we want the palindrome number, but provided that this palindrome number will be a prime. So we want prime numbers. We want to extract the prime numbers which are palindrome prime numbers. So for that, you are writing a function, and the name of the function will be is palindrome prime, which will be taking a number in it. And again, the outcome of this function will be like the Boolean value. So it will just give you whether the given number is palindrome prime or not. Okay, right. So it will just take a number and give you whether the number is palindrome prime or not. It will not print anything. It will just return a Boolean value. Okay, so a literal, a true or false. That's it. And the next one is m prime, emirp, like you say, which can be read like this. It is like prime. Okay, so which means that so for example, so if you just look into this example, the concept will be clear to you that say 17 is a prime number, and the reverse of 17 is 71, and 71 also need to be prime. Okay, so then you call them as emits. So or else you can say reverse read it like it will be prime. Okay, so reverse, okay, of a number also need to be a prime. Okay, so that's what you need to do in the prime module. You just need to write another function which is is-emer, and then which will be taking a number, reverse a number, and first of all it will check. That's how I have written the logic. I have written the logic in such a way that I am taking the number. First, I'll check whether the number is prime or not. If it is prime, then I'll reverse. Okay, because if it's not prime, then there is no point in reversing it. So then I'll reverse the number and find out whether the reverse of it is prime or not. So that's what is the logic I adopted to. And if both are primes, then again it returns a Boolean value saying that whether it is emirp or not. So that is the third function that you need to include in the prime module. And next one is Mercenary Prime. Okay, so this Mercenary Prime means that, so there is a formula 2 power p minus 1. For example, take 30, take 30, you can take 5 or whatever it is. Okay, so 5 is a prime number. So what I'll do is I'll put 2 power 5 minus 1. 2 power 5 is 32, right? So 32 minus 1 is 31. So 31 is also prime. Okay, so such kind of numbers are called as Mercenary Prime. Say for example, I'm repeating it once again for you to understand it. So say I'm taking 5. So the prime number that I'm taking is 5. Okay, first thing is I need to check whether the given number is prime or not. If it is prime, then I'll put it in the formula like this, which will be 2 power the number that I have taken. So say for example, I had taken number 5. So 5 is prime. So now I'll calculate this. So 2 power 5 minus 1. 2 power 5 will give me 32. 32 minus 1 will be 31. So I'll check whether 31 is again prime or not. If again 31 is prime, then I call that number as Mercenary Prime. So this is again another function that you need to write in the module prime. And the last function that you need to write in the module is twin primes. Twin primes means that the difference between the two prime numbers should be 2. Okay, so for example 3 and 5 are twin primes because the difference between 5 and 3 is 2. Okay, so such kind of numbers are called as prime numbers, provided both the numbers need to be prime and the difference between the two numbers should be 2. Okay, two prime numbers should be 2, then you call them as twin primes. So you just need to print the twin primes within the specific range that the user mentions. So these are all the module methods that you need to include in the module prime. Okay, right. Now what you should do is you should write another program. So the name of the program should be test.py or whatever. You can name it whatever you want. And in that particular program, you need to import this prime module and perform the operations like mentioned below. Like what are the operations mentioned? So the first one is prints first 100 prime numbers. So you need to call this prime function from the prime module, is prime function from the prime module, and print the first 100 prime numbers. So here what you're doing is in the test.py program, you are making use of is prime function from the prime module, and you will be printing the first 100 prime numbers. So that's the first task. Second task will be like print first 100 palindrome prime numbers. So to do that, you need to make use of this is palindrome prime function to print the first 100 palindrome prime numbers. And the third thing is like you are making use of all these 5 functions that are there in the prime module, and print the first 100 emif numbers, and then print all mercenary prime numbers for the p value, wherein for all the prime numbers below 32. Okay, so that's regarding this mercenary prime. This is a bit complicated one because why they have given a smaller number over here is because 2 power the prime number, right? If as it have a bigger value as the power, then the calculation takes time and your program will take a quite visible pause to print the outputs. Okay, so that's why less number is taken. 2 power 32 is again a very a long number that you get. Okay, fine. So even 32 is a very big calculation that it need to make. So, but anyway, that is mentioned in the case study. And the last one is prints all. So you just need to print all the twin prime numbers below 1000. Okay, right. So this is actually the case study which will be on module. So here you will be writing 2 programs. One program will be for prime.py, wherein you will be including all these functions inside that prime module, and you will be writing another program which will be test.py, and inside this test.py you will be importing this prime module, and you will make use of all the methods, all the functions that are there in the prime module, one after the other, to fulfill this requirement that is mentioned in the case study. I'm creating the prime module first because I need to write the function first. So I'm saying prime1.py because I have created the module already. Prime is there with me, so I don't want to open that file. So I want to create a new one. So I'm creating a module which is prime1.py. So this is my editor wherein I just need to create the is prime. Okay, so according to the problem statement. So let me just copy the problem statement here, and so that you'll understand what exactly I'll be doing over here. So just take a look at the problem statement. So create a module prime. So that's what I have created here, prime1.py, and to include the following functions. So inside this module, I'm including the first function, which is prime, which will take a number and return boolean whether the given number is prime or not. Okay, so whether true or false. So let me just comment this off so that it will not come into the execution. Well, fine. So let me create the is prime function for you. So before doing that, anyway, because I need the math module to do many calculations over here. So I'm just importing the math module so that it will be handy for me to use the methods, functions that are there in the module. So you can say that this is what is the built-in module. I'm making use of the built-in module math. So this math module is having square root and all that, seal and floor and all these are there in the math module. So which I am using it accordingly. And prime is the user defined module. So I created this module prime. This math is the built-in module. So built-in modules come along with your programming language. You just need to make use of it. So then I'm starting writing my module function. So I have given the keyword def, and then the name of the function is prime. So I'm taking it as it is over here. Okay, so is prime. So is prime will be taking a number. So I'm just taking it is n. Okay, right, put the indentation. So after indentation, now if n is equal to 1, so I'll just return false because 1 is not a prime number. So I'll say return false. Okay, because according to the problem statement, it means that you just need to return true or false. You don't need to print anything, remember that. So that's what I have adopted here in my logic. You can write it however you want. You needn't follow my logic. You can also solve it in your own way. So then I'm taking elif. So inside this elif, I'm saying n is equal to 2. Yes, of course, n 2 is the only even prime number. So I'll say return true. Okay, fine. If it is other than 1 or 2, okay, so then I'll turn a loop. So the concept I told you yesterday, yesterday also we have worked out with the concept for the perfect number and all that. I told you that we'll be finding the divisors. So even for the prime number, you just need to do that. I explained you this already when I was explaining you the experiments for the while loop, wherein to show you the use of the while loop, how you will be making use of while loop. I have demonstrated the while loop with an example of printing the prime number, whether the given number is prime or not. So I think I needn't again stress back on what is a prime number and what is the logic and all that. So just to give you a one-liner, a prime number is a number which is divisible by 1 and itself only. So if you don't have factors from 2 through n minus 1, then you call it as a prime number. If you find any factors from 2 through n minus 1, then you say that it is not a prime number. So we are just adopting to the same concept, but I'm actually improving the algorithm by not getting through from 2 to n minus 1. I am cutting it off till half because as I told you yesterday also, for the perfect numbers, that there is no point in finding out the divisors after the half of the number, because for example yesterday we have taken the example of one perfect number of 28, wherein after 14 you don't find a divisor. So I'm adopting the same thing by improving the prime number concept over here. So I'm taking another uh, variable which is like the maximum value or whatever. Then I'm saying max, then I'll say maximum divisor. Okay, so I'll just say maximum divisor is equal to so math dot floor. Okay, and then I said math dot sqrt, and then I'll be putting n over here. So I'll be getting half of it. You can also take the seal. So then now here I'll be turning a loop. So for I or whatever. Okay, so for I in a range. So from where to where? So from 2 to max underscore divisor. Okay, fine. I'm not turning the plus 1 because you just need to include this max divisor also in the calculation. So I said plus 1. So I'm not turning the loop till you can also adopt it to the program that I have given uh, for the while loop. So you can also take the same logic, but I'm showing you with a different logic because I already have shown you that logic. I am showing you with a different logic, and this is the better logic than that because here I am actually optimizing the algorithm. The number of iterations, I'm reducing the number of iterations accordingly. So inside this for loop, what I'll do is I'll check for the if condition. So if n, right? So I have n here. So n mod. So I'll be turning the loop. So I is the iterating loop iterating variable. So I will be holding 2 first, and then 3, 4, and so on till max divisor plus 1 till max divisor. So if this is equal to 0, it means that uh, it is having a factor. So in that case, it is not a prime number. So I'll be just returning false. Okay, fine. If the loop exhausts, the loop finishes off till max divisor and still I don't find any factors, it means that it is a prime number. So I'll just return true if the loop exhausts, but I don't have a factor. So whenever I'm putting return, what happens is the rest of the code will not execute. So you know that. Okay, so whenever you write return inside the function will return to the calling function immediately. So when there is a factor, immediately I'm returning to the calling function. So if this loop exhausts, okay, the loop finishes off till the maximum, like maximum divisor, and after that it means that it is not having any factors. So in that case, I'll be returning a true over here. Okay, so this is the logic I adopted to, and the function that I have written here will just take a single number. It will just take a single number and find out whether the number, single number, say I'm saying n, and we'll find out whether this number is prime or not by returning true or false. Okay, so that's what will happen here. Okay, right. So this is my function module. So I'm saving it and I'm quitting it, quitting from it. So now I came back to the terminal, and now I need to write another function. So I am saying gedit. So test1.py will be my test program. Inside this, I'll be importing the prime module. So import, so the name of the module is prime1, right? So import prime1, and now I'll be writing my logic to this one. So let us take a look at this part. Okay, before this import, let me show you the question what I need to do inside my test program. Okay, so I hope you can see this, girls, all of you. I hope everybody is following my class. Are you following or not? Yes.
Yes, ma'am.
Okay, so what I'm doing here is I have written a test program and in which like I'm importing the prime module. So I have done that. And the next thing I need to do is I need to print the first 100 prime numbers. Okay, so I need to print the first 100 numbers. So let us try to do that. So after importing, so the first thing I'll be doing is, since it is written in the question itself, like print the 100 numbers, I don't need to prompt the user to give the range. Okay, so it is given here itself. So there is nothing to read from the console, from the keyboard. So I'm straight away performing my logic, because the question itself is specific on printing the 100 numbers. So here in what I'll do is I'll tell to the user that I'm printing the first 100 numbers. So the first 100 prime numbers are, so this is what I'm trying to convey to the user. And then so I'm turning the loop. So I'm turning the loop. So I'll be taking an iterative variable here for j in range, whatever. Okay, so x in range or whatever you can write. So it need to turn from 2 to 100, right? So I just need to include 100 also, because it's saying first 100 prime numbers. So that's the reason why I have taken 101, because the ending begin, this is begin and this is end, right? So it will be end minus 1, so it will be considered till 100. If I give 100, it will consider only till 99, so that's why I have given 101. Anyways, right, so this is my loop. And then for each and every value that j picks. Okay, so what exactly happens here is, so this comments do not work here, I just need to give a hash. Okay, fine. What exactly happens here is, in this for j in range means that j tries to pick up each and every uh, element from the given range. So initially it will be 2, followed by 3 and 4 and 5 and so on, till 100. Okay, so this is what will happen in this particular for loop. So initially j will pick 2, and after that what happens is, we are writing, so inside this for loop, so this is a for block, so I just gave an indentation here. And now I'm calling the prime is prime function from the prime module. So prime one dot, the name of the function there is prime, and then it takes a number, right? So here it needs to take j. Okay, fine. So I'm just checking on. So in case if it is a prime number, so it will return a true over here for me. Okay, so this will return the boolean value true or false. Okay, so if it is true, then what I need to do? Okay, so if it is true, of course it's a prime number. So I do have a print statement here which will print the prime number, and after the prime number, so that it doesn't get congested, because 100 prime numbers, if they print if they print vertically on the screen, so maybe I need to scroll up and down to find out the number. So I want all the 100 prime numbers to be printed horizontally, so that the visibility will be good, and I'm separating each and every numbers with the space. See how much I am thinking on, like this is what each and every student need to think. Okay, like how your output need to be, how well you need to present your output to the user. So all these things you need to take care on while writing your program. Okay, if it is false, I'm not catching it, I'm not writing an else here, because it's not mentioned in the question itself. Like I just want the 100 prime numbers, I don't want to write like this is not a prime number and all that. I just need the 100 prime numbers. So that's why I'm not putting an else part over here. Okay, it's a simple program wherein I'm turning a loop for each and every value that j takes. I'm calling the is prime function from the prime one module, and this will return whether it is true or false. And if it is true, because if evaluates to be true or false, okay, the condition it takes in the boolean consideration, and if it is true, then this print statement will be executed. If it is false, then it j goes to the next element, and again is prime is checked and all that. Okay, fine. So I'm saving this. I hope this is clear to everyone. So let me get back to the terminal and then execute the program. So I need to execute test one. Okay, so I'm saying Python 3 dot test1.py. What did I do? Okay, I gave a comments double slashes somewhere. Okay, I have given it in see, I have given this comments. Okay, this do not work here. They work in your C and they work in C++ and they work in Java, but they do not work here. Okay, right. You can put a hash or you can just put a. Okay, well, fine. So, right. Okay, so let me execute the program for you. Okay, well, girls, you can see the output over here. So I got 2, 3, 5, 7, 11, 13, 17, 19 and all that. So all these are the prime numbers within the range 1 to 100. So I'll get back to the prime module and then I'll write the method there. So this is my prime module. So this is what we have done for the is prime. Okay. So what is your next question? So your next question is like you need to have so this is your part B. So just take a look at what is there in part B. So you have this. Okay. So this is palindrome prime, which will be taking a number, returns boolean whether the given number is prime with palindromic example is 131, which is also a palindrome number as well as a prime. So let us just try to do this. So below it, I'm writing the function, so which is def. And what is the name of the function? I can also do over here. Okay. మీకు కన్ఫ్యూజన్ లేకుండా ఇక్కడ చేస్తాను. Okay, right. So this is my function, which is def, and then so this is the name of the function. So the name of the function is palindrome prime. So I'm just taking a number n into it, and it just need to tell me whether it is palindromic prime or not. So I have taken a flag. Okay, so flag is equal to, it can be 0 or 1 or it can be a boolean also. So initially it's okay, you can take true or false or whatever. Once you know the logic, you can just build it off. So I'm trying to do the reverse of the number by the same old formula. So I'm taking the number into n. Why I'm taking the n into number is because while turning the while loop, what happens is you'll be dividing the number by 10. So what happens is the number will become 0. Okay, so that's the logic. So I need the number also to find out whether the number is prime or not. So that's why I am actually keeping it into another variable, which is num. And here I'll be turning num. Okay, right. I'll be using it on num. And initially num will be greater than 0. But once the loop turns and it iterates, then the number will become 0. And that's when the loop breaks. Okay, right. So in here, I'm taking reminder is equal to the same old formula that you have applied. Okay, other than this, you can also try other methods of reversing a number. So then what you need to do, we need to say reverse is equal to then reverse into 10 and plus a reminder, right? So this is what I'm doing here. And then I'm saying num is equal to, so do the flow division. Okay, right. So this is what I'm doing. Okay, so wherein I'll be getting the reverse in the variable reverse. Okay, so to know whether the number is reverse of the number is also same as the number, what we'll do is that's the reason why we had a flag over here. So for that, I'll say if number, so I just need to give the indentation. So if n is equal to reverse, okay, fine. If n is equal to reverse, so then I'll be setting the flag. Okay, so I'll say flag is equal to true. Okay, so this means that the reverse is also same as a number. So which means that it is a palindrome. If flag is set to true, it means that the number is palindrome. Okay, so the number is palindrome. Our problem is not over yet. We just need to figure it out whether the number is prime or not also. So for that, you can also use this method, which is already written in your module. Okay, you can call one function, can call the other function also. You can also use this particular method inside this, but I'm not doing that. I'm specifically writing it, so it will be a practice for the students. So I'm not making use of this function inside this, but you can also do it. Okay. So again, the same thing, I'm writing these statements and all I'll be writing. I'll say if n is equal to 1, then return false. If it is equal to true, return true. And then finally, I'll have an else, inside which I'll be turning a for loop. So for I in range, so for I in range, so I'm adopting the basic uh, formula that I have given for prime numbers in the while loop example. Okay, so I'm showing you all the variations of writing, finding out whether the given number is prime or not. Okay, so if now n mod I is equal to 0, so it means that it is not a prime number. So what I'll do is I'll say return false. Okay, right. And I don't need an else part over here. So if the loop comes out, okay, so exhaust till the n value, it means that the number do not have any factors or any divisors. So now it means that it is a prime number. I can simply say return true, but you just need to check one more thing over here, that whether the flag is true or not. Okay, so if a flag is equal to, so it's lowercase here, so this is also lowercase. So if a flag is equal to true, then only you will be returning false. Okay, then only you will be returning true, else you will return false, meaning that it is not a palindrome. We just want, it is a prime number, but it is not a palindrome. So you don't want such numbers. You want a number which is palindrome as well as prime both, right? So that's why you're checking for this condition. So if the flag is true, it means that it is a palindrome. If I come out of this loop, it means that it is a prime number. So that's why you're writing this statement here. So if it is true, means that it is a palindrome. Since I have come out of this for loop successfully, it means that it do not have a divisor. So it means that it is a prime number. So it is prime as well as palindrome. So I'm returning true over here. Okay, fine. I need to have an else also here. The reason is that if I come out of this loop, okay, so it means that it is a prime number. And if this condition is false, it means that it is a prime number but not palindrome. So I need to actually look into that path of execution also. That's why I'm returning and having another else over here, which will return a false for me. Okay, so that's it. This is the module is palindrome prime is the module which will actually check whether the given number is palindrome prime or not. So I'm saving it, come out of it. Now get back to your program, which is test.py. So herein, I just need to know the problem statement again. Go to your problem statement and look into it. So it says prints first 100 palindrome prime number. So I just need to do that. So the second thing that I need to do in the test is that print first 100 palindrome prime numbers. So for that, what I'll do is I'll just copy this and paste it, not to waste time. So I just want the first 100 palindrome primes, right? So I'm saying palindrome prime numbers. So the first 100 palindrome prime numbers are, so I'm just turning a loop over here. So what I need to do in the loop, so I need to turn the loop from 2 to 100. Okay, so 101 over here, and then prime 1 dot, what is the name of the method? It is palindrome prime, right? So the name of the function is palindrome prime, and which is j, and I'm printing j and all this. Okay, well, fine. So that's it. So let me execute this and show you. So we are here. So well, girls, so these are your palindrome prime numbers. So let me order it properly. Okay, so now your answer is more readable. So I hope everybody can see the answer. So the first 100 palindrome prime numbers are 2, 3, 5, 7. Individual numbers are obviously palindrome numbers. So the other palindrome number in the range of 100 is 11. So since the output for is not, I mean, for the 100 palindrome prime numbers, you don't have many palindrome prime numbers within the range of 1 to 100. So that is why what I have done is, inside your manual, I have made it 200. Okay. So that's the reason why I made it 200. Okay, because you'll understand it better. So that's why I made it 200. If you just look into your manual, in your manual I have made it 200. Okay, so now you can see, like, you can actually process like whether your answer is correct or not. So the debugging happens better. So that's why I have made it 200. So you can see 101 is the other palindrome prime number after 11. So which is 101. Okay, and the other one is 131, and the other one is 151, 181, and 191. Okay, so these are the palindrome prime numbers. Okay, so if you really want to know whether these are prime numbers or not, you can also get back over here and make your prime numbers list to print till 200, and let us check. Okay, debugging your program is very important. So you can see that. Okay, so 101 is a prime number, and 151 you can see is a prime number, 181 is a prime number, and then 191 is also a prime number. And among all these prime numbers, the palindrome ones are picked, and this is what you got as an output. An emir number, so it should be a prime number, and the reverse also should be a prime number. Okay, so what I did is, this is E is emir, this is the name of the function. So E is prime, I'm calling it. If it is true, then I'm working it out. Okay, so I'm finding out the reverse of it, and then I'm calling again the E is prime on the reverse number. If it is true, then I'm returning true. That's it. Okay, right. So this is what I'm doing it in emir. Okay, right. So in the in the test, what I have written is, this is what I have written in the test. Okay, so I want the first 100 emir numbers. You can just take 100 or 200, whatever it is. So let me execute this and show you. Okay, so this is the answer for the first 100 emir numbers. I have not changed it. Okay, so it should be the first 100. Okay, anyway, this prime numbers, I'll keep it. Okay, I'll keep it till 200, because you'll be able to process, debug the rest of the things. Okay, the reverse and all that you will be able to make it out. So I am just keeping it to be 200, the prime numbers. So let me execute this Python 3 test1 .py. So you can see these are all the prime numbers from 1 to 200, and these are all palindromic prime numbers from 1 to 200, and these are the emir primes which are from 1 to 100. So you can see like 11, it's obviously a palindromic prime, and it is also an emir one. 13, you can see like the reverse of 13 is 31. 31 is a prime number. Okay, so that's why we got it. 17 is a prime number. 71 is also a prime number. So you can see it over here. And 31, I told you. 37 again is a prime number. And 73 is a prime number. The reverse of it is also a prime number. Then 79 you have is a prime number, and 97 is a prime number. Okay, so all these are the emir prime numbers. Is it clear, ma?
Yes, ma'am. Yes, ma'am.
Okay, so what is the next question?
Yes.
Okay, it is Mercenary Prime. So you just need to do the calculation, that's it. Okay, what you need to do is, so let me just explain you this problem statement. Let me get back to terminal. Okay, I'll get to this one and explain. Okay, what is this Mercenary Prime means that okay, well, fine. So what you'll do is, say for example, n is equal to 5. Okay. So first check whether 5 is prime or not. Okay. The algorithm. Okay, I'm giving the algorithm. So again, the question is like print all the Mercenary prime numbers for the p-value below 32. Okay, so these two are the considerations for us for solving this. The first thing is like they are asking us to print. The case study is mentioning that we need to print the Mercenary prime numbers for the p-value below 32. Means that I need to consider the numbers from 1 till 32. First thing is I need to check whether this number is prime or not. So it will start from 1. Okay, so n will start taking. So here we are saying 2 power p. So p is nothing but the prime number. Here it means that it is a prime number. So this is the range. Okay, so p from 1 to 32. And among these numbers from 1 to 32, I'll pick the prime numbers. So I'll pick the prime numbers from the range 1 to 32 for each and every prime number. Say for example, I'll take 2, okay, and see 2 power 2 minus 1, and it's an expression, and whether the result of the expression is also a prime or not. Okay, so that is actually the task over here. So say for example, let me give you an example. Say for example, p is equal to 5. Is is a 5 a prime number? Yes, 5 is a prime number. So it is a prime number. So the first thing that I need to do in the algorithm is check whether the number is prime or not. So the number is prime. So once the number is prime, now you do this calculation, which is 2 power p minus 1. It is this is not a proper text editor, so I'm not able to put it on top. So let me show it in terms of your Python calculation. So this is what is 2 power p, right? So this is an exponentiation operator. So double asterisk represents an exponentiation operation. So 2 power p minus 1. So this is what is the expression that you need to evaluate. So once you evaluate this expression, you'll get a result, right? So you'll get some result. So the result of this expression, okay, so say I got the result as R. Now I'll check whether R is prime or not. Okay, so I'll check whether R is prime. So if P is prime as well as R is also prime, then I'll say that it is a Mercenary prime number. Okay, so I hope the algorithm is clear. The problem statement is clear to my class.
Yes, ma'am.
Yes. So how do you carry forward it? You take each and every number, see whether it is a prime or not. So this is the first step of your algorithm. Once you know that it is a prime number, you can also put a flag or whatever you want, you can do it. So for this EMIRP numbers, I haven't taken any flag. Okay, so I have directly calculated it in the if statement. I'm showing you different ways of approaches to solve a problem. So here I can directly do it in a statement. I can say if E is prime and call it. But I want you not to use the functions, write the program again and again. Use the same logic of prime numbers again and again so that it becomes a practice for you. Okay. So do not use the existing code. That's the reason why in the prime module I have not used the existing code. I just showed you how to use it in one or other examples, but rest of the cases I have written the code. Okay, right. So the first step is check whether the given number is prime or not. If it is prime, then calculate this one. If it is not prime, then there is no point in evaluating this expression. So I'll ignore this if it is not a prime. If it is prime, then I'll do the calculation, get the result in R or whatever, and then check whether R is prime. If both the number and this R both are prime numbers, then I'll say that it is a Mercenary Prime. So this is how I'll be solving the third one. And coming to the next one, print twin primes. So here in the method itself, in the function itself, you need to print the twin primes. It is not returning. So here it says prints all twin prime numbers below given range. So you needn't give the boolean and all that. Directly in the method itself, you can, in the function itself, you can print the twin prime numbers. And I gave you the formula for the twin prime numbers. So the formula is that the difference between the twin prime numbers will be 2. Like for example, 3 and 5, all these are prime numbers. Okay, so you just need to solve it in such a manner.